Section 5.2 is all about mortgage loans. So what is a mortgage? Well, according to Investopedia.com, a home mortgage is a loan given by a bank, mortgage company, or other financial institution for the purchase of a residence, a primary residence, a secondary residence, or an investment residence, in contrast to a piece of commercial or industrial property. In a home mortgage, the owner of the property, the borrower, transfers the title to the lender on the condition that the title will be transferred back to the owner once the final loan payment has been made and other terms of the mortgage have been met. So let's look at the terms of a mortgage. Well, the first term of the mortgage happens when you're actually buying the property. When you buy the property, the bank will put their name on the ownership documents as a lien holder, and you'll sign a contract with the bank stating that you will repay the loan according to its terms. And what a lien holder is, it's anyone who is funding the loan. So typically that's the bank, and they have a financial claim to the collateral for which the loan is for. So the collateral would be your home. And what that's saying is if I default on this loan, meaning I don't pay it back, that they get to keep the collateral, which would be my home, in exchange for me not repaying the loan. A mortgage payment itself is going to be based on the total value of your loan, so how much money you're actually borrowing, the annual rate of interest, because everything is given in APR, the length of time that you need to borrow the money, and the frequency that you are making that payment. So if you want to calculate your payment, you need to convert everything into like terms. So for example, if your payment is going to be monthly, then your interest rate must be a monthly rate, and your number of payments are going to be based on the number of months. If your payment is made annually, then the interest rate must be on an annual rate, and the number of payments are going to be based on the number of years. Now there's actually 3 different methods that you can use to calculate a mortgage payment. There's actually more out there, but this is just kind of 3 main ways you can do it. The first one I'm going to show you or talk about is going to be using a loan amortization table, and this is actually what the book does. So they take a table, and in this table you have percentages of the different interest rates, and you have a length of time that you're borrowing the money. And you would take that and multiply that rate times the amount of your loan divided by $1,000. So for example, if I had a loan for $10,000 and I was going to pay 5% interest on it, and it was going to be a 10-year loan, I would find 5% interest and 10 years, and that would put me kind of right about here on this table. And I would take this amount here and I would multiply that by 10,000 divided by 1,000. So I'd take that amount, I'd multiply it by 10. The next way you can do it is using a loan formula. So for example, let's say that my interest rate is 3.37%. Well, that's not in that table. So I'm going to need to use an amortization loan formula. And this is the formula that you can use. This is the interest rate. R is the interest rate. And you would convert this into either an annual rate or a monthly rate, depending on the frequency of your payments. And then T up here is time. And so that basically is saying how many payments are you actually making. So you take your loan amount, divide it by this information, and that will give you your payment. The last way to do it, and probably the easiest way to do it, is to do it in Excel. So if all you wanted to do was to know what your payment was going to be, you can use this formula. You can type in any cell, you can say equals, type PMT, put a parenthesis, then type in your rate, and remember to convert your rate to either an annual rate or a monthly rate. NPER is your number of payments. And then I have something that says PV. That's the loan amount, which is really the present value of the loan. That would be the way to calculate only your payment. However, they also have some spreadsheet solutions in Excel that are templates set up where you could see an entire loan amortization schedule, meaning it would show you how much interest you're paying. It would show you all kinds of information all about your loan. So if you wanted to use a spreadsheet solution, it would give you more information than just the payment amount. So we're going to look at one practice problem, but we're going to solve it all 3 ways. Paul wants to build a building for a church. The purchase price of the building is $350,000. He will put 20% down on the purchase. The terms of the loan are as follows. He's going to pay 4% interest. It's going to be a 20-year mortgage, and he's going to pay this monthly. So how much is the initial loan? Well, in order to calculate that, I can calculate that by basically taking, this is the amount of the purchase, and I need to subtract off 20%. So I'm going to take my $350,000. I'm going to multiply that by 0.20. That's my 20%. And when I do, that's going to give me $70,000. Well, that's how much I'm putting down on the loan. That means I don't need to borrow that amount. So I can take my $350,000, I can subtract off my $70,000, and that leaves me with $280,000. That is how much I need to borrow for the loan. The next question says, is how much is his payment? Well, in this case, I'm going to use the loan amortization table. And as I mentioned, this is per $1,000 that you're borrowing. So I'm borrowing $280,000. That means that I would take the amount in this table and multiply it by 280 because it's per 1,000. So here I have 4% interest. It's a 20-year loan, and that tells me my factor that I'm going to multiply it by is 6.06. Now these have, even though this says 4% and even though this says 20 years, this payment amount is actually already updated for this being a 20-year loan. So that means that this 20 has been multiplied by 12 to say that's how many payments I'm making. And this interest rate right now is an annual interest rate, and this would have been converted into a monthly interest rate. We'll see that actually in the next problem. So to figure out what my payment is going to be, I'm going to take 6.06, I'm going to multiply it by 280, and that's because I took this 280,000, divided it by 1,000, and that means that my monthly payment is $1,696.80. Now the next question says, how much interest did he pay on the loan? Well, in order to figure out how much interest he paid on the loan, this is actually a two-step process. And what that means is that I first need to figure out how much did he actually pay overall. So if I take the payment amount of $1,696.80, I multiply it by the number of years I've paid on this loan, and I multiply it by the number of times per year I paid, which is 12. So I paid on it for 20 years, and every year I paid on it 12 times. The amount that I actually paid in total is $407,232. So $407,232. Subtract off the original amount of the loan. Because I borrowed, I needed $280,000 to borrow. So I paid $407 total. Only the loan amount that I was paying off was $280, so the rest of that is interest. And that means that in interest, Paul paid $127,232. Okay, so that is how you would use the loan amortization schedule, or table. Now, if I wanted to calculate this instead using a formula, I can do that as well. Now we've already calculated some of this information. This is the exact same information. We still have a loan for $350,000. Up here, this is the same. We're putting 20% down on this loan. We're paying 4% interest, 20-year mortgage, paid monthly. How much is the loan? Well, I already calculated that out. That is not going to change even though I'm using a formula. This is the formula that I'm going to use. So what changes now is going to be the rate, and I now need to take into consideration the time. So I'm basically plugging my variables into this loan. So let's go on ahead and calculate R in this case. So R is a 4% interest rate. So you may be thinking, okay, well, R is going to be 0.04. That's not quite true. R is going to be 0.04, but that's an annual rate, And I need to convert this into a monthly rate because this is paid monthly. So I'm going to take that, I'm going to divide it by 12, and that's going to give me 0.003 repeating. My T is also going to change. So up here, T is time, and you may be thinking, okay, well, it's for 20 years. Well, that's not quite it either. It's 20 years, but I'm making my payments monthly. So that means I need to multiply that by 12 because I'm not making 20 payments. I'm making 20 payments times 12. And so that's going to give me 240 payments is the number of payments I'm actually making. Now that I have this information, I can actually plug it into my formula here. So my loan amount is $280, and I'm going to take all of that and I'm going to divide it by, I'm going to put this on here, 1 minus, and then it says that I have, I guess I have a bracket here, 1 divided by 1 plus, and I've got the rate, so that's 0.003. I'm going to take that to the power of the time, which is 240. And I'm going to take all of this and I'm going to divide it by my rate of 0.003, and these are 0.003 repeating, and that's going to give me my payment. And you'll have to use the order of operations to actually solve for this, but if you were to do this, your payment would actually be equal to $1,696.74. So when we used the table before, in the previous example that I did, it gave me 1696.8. Well, because I used specific numbers, like very real numbers, and I didn't have any rounding, now it's saying that it's 1696.74 cents. So that's going to change a little bit. This is actually a different payment number just by 6 cents. All right, so that's his payment based off of using the formula. Now it says how much interest did he pay on the loan? Well, this is going to kind of be the same way that I would calculate it out as I did in the previous one. I would take my 1696.74, multiply it by the number of years, multiply it by the number of months, and when I do that, it's going to give me $407,217.60. I'm still going to subtract off the original amount of the loan. And when I do that, the amount of interest I paid is $127,217.60. So it's barely different. And the problem before, my answer was $127,232. Now I've got $127,217.60. So it's really only different by about $15. But rounding does make a difference. So this one has no rounding, whereas using the table had some rounding. So let's go on ahead and see how easy this would be to calculate the same information in Excel. Okay, I've got Excel pulled up here, and we're going to calculate this exact same information using Excel. And Excel actually is pretty easy to use because it just acts as a calculator for you. So you don't even need a calculator to calculate this information out separately from using Excel. So Paul still wants to buy a church. The price of the purchase is $350,000. He's going to put 20% down. The interest is 4% per year. It's a 20-year mortgage, and he's going to pay it monthly. So what is the initial amount of the loan? Well, to calculate the initial amount, I need to first figure out what the down payment is. And so I'm going to go on ahead and type down payment next to this cell that I'm going to use as my formula. That way I can see what number I'm calculating. To use Excel to do all your calculating for you, you just type in it in certain ways and it will calculate for you. So if you want to put a formula in here, the first thing you need to do is type the equal sign. So I'm going to put equals. I'm going to take the amount of the purchase price, which is $350,000, and I'm going to multiply that by 20%. Now in Excel, I need to convert everything to decimal format. So I'm going to type in 0.2, and then I'm just going to hit equals, and it's going to show me the amount of the down payment. I don't particularly like this format because even though I know that this is $70,000, there's no commas in it, there's no decimal spaces to show me if there's any change. I just don't really like this format. So we can format our numbers using this formatting area up top. I can click on $ if I want it to be in accounting format. And what that does is it puts a dollar in front of the numbers and it gives pennies down here as decimals. You can use the accounting format. I personally am not a huge fan of the accounting format just because every time I type in a number, I already know that everything I'm looking at is amounts, so I don't necessarily want to see a $ in front of everything. If you do, leave the $. If you don't, but you want to see all the commas, use this comma format. And what that does is it puts commas in place. When I put my mouse over it, it says formats with a thousands separator. So for every group of thousands, it's going to separate that with a comma. You can also change the number of decimals that you have if you want. If you want to see less decimals, you can say decrease decimal. And I'm clicking on that twice. That gets rid of all my decimals. If I want to see more decimals, I can increase it and have more. For me, I like seeing 2 decimals, and that's because this is in dollars and cents, and I like to see the 2 decimal places. I also don't want to go through and have to update every cell individually every single time I put in a formula. So I'm going to go up to this column header right here, J. I'm going to click on it one time and highlight everything that's in this column. I'm then going to click on the comma, and it's going to turn everything in this column into that comma format. So every time I type a formula in here, it's going to give it to me in that comma format, which is my preferred format. All right, so I know my down payment now. Now I want to calculate out how much is the loan. So I'm going to type loan amount right here. If I want to know what the loan is, I'm going to again say equals for my formula, 350,000. But instead of typing in 70,000, I can click on this cell. And what that does is it references that cell so that if this cell ever changes, then this number would change. So I really like referencing cells because it makes it less likely that you'll have an error. So I've typed in the 350,000 minus the down payment cell, and I'm going to hit enter, and it's going to do the calculation for me. So my loan amount is going to be for 280,000. And like I mentioned, if I change this cell, let's say I want to say that the amount he's putting down is 25%. I'll go up here in my formula bar. I'm going to change this to 25. When I hit enter, it changed the down payment and it changed the loan amount. So I really like referencing the cells. I'm going to go on ahead and change this back just so that we can use these numbers for our example. So my loan amount is 280,000. Question number 2 says, how much is this payment? Well, here I'm going to use that formula that I showed you in the slides. And the formula, again, starts with an equal sign. And this time I'm going to type PMT, and that's the payment formula. And right here you can see that it says next to this PMT, it says calculates the payment for a loan based on a constant payment and a constant interest rate. So the payment doesn't change and the interest rate doesn't change. All right. So in order to start filling this in, I have to put my first parenthesis. And when I do, it gives me information about the things I need to put in each section right before a comma. So the first thing I need to put in here is my rate. My rate is talking about my interest rate. So my interest rate is 4%. I need to put this in as a decimal. In addition, because this is a monthly payment and not an annual payment, my interest rate also needs to be a monthly interest rate. And in order to do that, is it's basically saying I have 4% that I'm paying for the whole year. If I divide that by 12, that tells me how much interest I'm paying in a month. So I can go on ahead and just put the formula in. 0.04 divided by 12. That's going to be my rate. I don't need to calculate it out separately. I can do it in Excel. I'm going to type my comma, and that's going to take me to the next item it wants me to type in. I have NPER. What this stands for is this stands for number of periods. That's the number of times that this payment is going to be made. Well, I'm making it for 20 years, and I'm going to be making the payment 12 times per year. So in this case, 20 years times 12. Now you'll see onto this number that says PV, and then after it, it says FV. So PV and FV stand for present value and future value. Present value would mean I know the amount of the loan today. Future value means I know the amount that I'm paying the bank in total. That would be interest and the loan amount. I don't know the amount that I'm paying in total, I only know the amount of the loan, so I'm going to use PV. You would never fill in both of these numbers. You would fill in one or the other. So in this case, I know the PV, I don't know the FV. The other unique thing with Excel is I can't type this in as a positive number. I have to type it in as a negative number. If I type it in as a positive number, my payment amount is going to be a negative number. If I type it in as a negative number, my payment amount will be a positive number. So if you ever forget and you type it in as a positive, you'll see very quickly the payment amount comes up negative. You can fix it very easily. It's not a big deal. Also, I'm not going to necessarily type in 280,000. I can just click on this cell up here and it will reference it. And I love referencing cells, as you can tell. So I just clicked on the cell. I didn't have to type in the amount. That way, if anything changes, this would be updated immediately. I've already mentioned I wouldn't use both FV and PV. The last item it has here is type, and I'm not going to use that either. Type refers to when the interest is accrued on the loan. Is the interest accrued at the beginning of the time period or at the end of the time period? And in this case, we don't need to worry about the type because this payment is already set up to accrue the interest according to the terms of paying off the loan. So you would really only need to do that if you had an annuity due, which is basically a loan payment where the interest accrues at the beginning. If it accrues at the end, you don't really need to worry about it. And in this case, we don't need to worry about it. So I don't need to type anything else in. I'm just going to put my end parenthesis on here and I'm going to hit enter and it's going to give me a number. Now, that's the same number we saw with the formula. When we calculated out the formula, we got 16,966.74. The next item down here says how much interest did he pay on the loan. So we're going to start by calculating this the same way that we would have calculated it if we were doing it with the other two methods. We're going to say, okay, we're going to take our payment amount and we are going to multiply this times the 20 years and multiply it times the 12 months. Now I have a little bit of a problem because when I calculated it out with the loan using the formula, it actually gave me the number 407,217.60. That was the amount that I got. I'm going to go ahead and change my format. This is the amount that I got based off of the formula. And you'll see that these two are different. So why are they different? Well, what happened is this amount here is not actually rounded to 2 decimal places. If I were to increase the decimals, you can see that there's actually several numbers after this. It doesn't stop at 0.74. It keeps going. So this amount is calculating based off of the non-rounded number. In reality, we are going to be paying a rounded number. And so the number I really want to use is going to be, and I can still reference it, but I'm going to need to put a formula in here to do that. I can say equals, and I want to round this number here to 2 decimal places is what I want to do. So now this number is now going to be rounded to 2 decimal places by saying round, put that in there. I'm going to multiply this now by my 20 payments and multiply that by 12. And when I do, it's going to give me the exact same number that I had when I used the formula. All right, so this is the total amount that was paid on the loan if I don't round it, and this is the amount that was paid on the loan if I do round it. So the amount that I paid in interest, I'm going to say equals this amount minus my loan amount. And I'm, whoops, this has a minus sign in front of it. Let's fix that. Again, equals this amount minus the loan amount. And I'm leaving both of these on here for a reason. This would be really the correct amount is what this would be. This is the amount of interest that you paid on the loan. This one, because it's based off of rounding, not quite correct because this has more than just 2 decimal spaces. You'll see why I left this in just a moment. I had mentioned also in the presentation that there is a pre-made spreadsheet that you can use that gives you all kinds of information. So I'm going to right click on this spot down here that says Sheets, and I'm going to say Insert. And what I want to insert is a new sheet down here. Now, This is just general types of sheets. I want to go to Spreadsheet Solutions. And when I do, I have one called Loan Amortization. I'm going to click on that and say OK. Now this is a pretty cool sheet. You can type all of your information in for your loan and it will give you an amortization schedule. So my loan amount is going to be $280,000. The annual interest rate is 4%. The number of years I'm paying on this loan is going to be 20 years, and I'm making 12 payments per year. You have to pick a start date of your loan. It doesn't really matter if you use a real date or whatever date you use. If you're doing this for personal reasons because you want to have a loan and you want to see different information on it, then use the date that the loan starts. For our purpose, it doesn't really matter. I'm just going to say 1/1/2022 because this is just an example. Now here's what's cool. This puts in here all the information that I would want to know about this loan. It gives me my beginning balance. It shows me my scheduled payment, which is a $1,696.74. Of this payment, it shows how much goes to principal, which is the part that pays off the loan, and how much of it goes to interest. I have an ending balance of my loan, and this shows how much is left on the loan to pay off. If I wanted to pay the loan off after making one payment, how much would I need to pay? This is the amount I'd need to pay, and how much interest is accumulated because I made this payment. This is how much interest I've paid as of certain dates. And as I go all the way down to the end of this loan schedule, which I'm getting there, you can see here that I paid interest of $127,218.78. Now here's why I left both of these numbers on this sheet here. The loan amortization schedule is using the unrounded number. This is what the loan amortization schedule is using. In real life, a bank would not use Excel to calculate this out because this number never gets rounded. If this number got rounded, then we would owe probably another $1 or so on that final payment is in here. And as you can see here, this final payment is rounded. So it would be updated just a little bit. This would be my scheduled payment. This is the balance. This final payment gets updated based off of what needs to be paid on the loan. So in real life, your payment would never be rounded, and this is taking into consideration rounded payments. And that is not what you want to do. However, using the loan amortization schedule, because it's a difference of like $5, not even $5, it's a difference of $1. As you can see here, it's only a difference of $1. Using a loan amortization schedule is fantastic because it has other features you can use, especially when you're trying to consider what your savings would be if you paid extra money. So let's say Paul made this payment, but he made an extra $100 a month payment on it. Well, before making that $100 a month payment extra on the loan, it was the number of payments he had to make was 240 payments. Well, now if we go down here, because he paid an extra $100 a month, he only has to make 221 payments. This would help him pay the loan off much faster by making those payments. In addition, he had a lot less interest that he paid. So here, if he pays an extra $100 a month, he's only paying $115,676 in interest, where if he didn't make that payment, it was $127,218, give or take. So what's great about the loan amortization schedule is you can figure out how much faster you'll pay your loan off, how much interest you can save by paying more money on your loan, and this gives you a ton of extra information as you consider your loans. So don't write this schedule off. This is actually a great schedule to use.